Hey, this is Horner. We're going to take a look at the momentum free response question number one. And when we look at this, we see that students are trying to go through the conservation momentum, and they're looking at two unequal mass carts, number one and number two. They move on a frictionless bearing, and it is on a horizontal straight track. They perform an experiment in a trial in which cart one goes and it collides with cart two, and they have motion detectors measure the motion. So the positions of cart 1 and cart 2 are shown as functions of the two graphs that you see below. And so what we'll do is let's go ahead and we see that position versus time, this would be the original velocity of cart 1, and this would be the final velocity of cart 1. Then over here, this is the original velocity of cart 2 and the final velocity of cart 2. So at this point, they want to know, after taking the above data, but before measuring the masses, one of the students states that it's obvious here that cart 2 has more mass than cart 1. So we really just want to check and see if this person can do that from the graphs. And there are 3 points that you need to make here. If you talk about 2 of the points, you get 1 point, and if you talk about all 3 of them, you get 2 points. So let's go through each one of these points one at a time. So the first point here is just by saying that the velocity of the carts is the slope of the line. So if you do that, you're good. We can see for the second point that the change in velocity for cart 2 is less than the change in velocity, for cart 1. This one has a big change in velocity. You see it's positive here and negative here. Here, this one goes from 0 to just a positive value. And then the third point here is just saying that mass and velocity are inversely related. So they are inversely related. And by inversely related, we know that m and v is equal to p. And so if we go through and do this, we can say that m would be equal to or proportional to 1 over the velocity. So the velocity change here was not very big. So if this is small, we know that the mass has got to be large. Here we've got a very big velocity change. And so since we have a big velocity change, we know that we've got to have a very small mass. So this is a small mass, this has got to have a big mass, and those are the 3 points. So the next point here says the students measure the masses of the carts, and they do indeed see that this one is 0.2 kilograms, and this one is a lot heavier, it's 0.7. So 0.2 kilograms, and this one is 0.7 kilograms, 0.2 kilograms. And they want to know, does the experimental evidence actually support this? So there's 3 points for this one. The first point is saying that the initial velocity of cart 1 is equal to 0.5 meters per second. And they did that by finding the slope of this line. And you'll see that it's basically, if you start here and go here, you can use any 2 points on the line, but 1 over 2 is going to be a half. And then over on this side, you'll see that the slope for this part is going to be the final velocity of cart 1, and that's equal to negative 0.2 meters per second. For cart 2, the original velocity is 0 because it's horizontal. And then if you find the slope of this line, you're going to find out that the final velocity of this cart is going to be a positive 2 meters per second. We know that this cart has a mass of 0.2, so the original velocity of cart 1 plus the original velocity of cart 2 is going to be equal to the sum of the momentum. So let's go ahead and figure that out. So we're going to take 0.5 and multiply that by our mass, which was 0.2. And if you do that, half of 0.2 is going to give us 0.1 kilogram meter per second. And then over on this one, we've got no velocity for the second one, so we're just going to add that to 0. So this is the momentum of the system before. Let's find the momentum of the system after. So we've got P1 plus P2 again, but this time it's final momentum. We've got a negative 2 because that velocity is negative times 0.2. And if you take negative 2 times 0.2, so we're going to take 0.2 times that negative 0.2 you're going to end up with negative 0.04. So this is negative 0.04. And we're going to add that to the final momentum over here, and it is 0.7 times 0.2. So 0.7 times 0.2 gives me 0.14. So this is 0.14. 0.14 minus 0.04 gives me 0.1 kilogram meter per second. So at this point now, because we found the original and final velocities for both, that's a point. You get a point for finding the original momentum, the sum of momentum, so that's a point. So it was 1 point for finding all of these velocities. And then finally for finding this is our last point, and we see that these two are the same. The very last thing says, does the experimental evidence support the assertion that that collision is elastic? So we want to know, is this collision elastic? And we need to figure out what the kinetic energy is of both of the original and final. So we know kinetic energy is just 1/2 of the mass of the first cart times the original velocity of that first cart squared. If you do that, you're going to get 0.025 joules, and the other one doesn't have any kinetic energy, so it's 0. So that is the original kinetic energy. The final kinetic energy we've got to find from the two kinetic energies. The first cart has a velocity of negative 0.2, and so we can take 0.2 times 0.2. So 0.2 times 0.2 is going to give us 0.04. So that is 0.04. And then we're going to do 1/2 of the mass, which is 0.2 times 0.04. And if you do 0.2 times 0.5 times 0.04, we end up with 0.004. So this is 0.004. And then we need to add it to the kinetic energy of the second car. And so the kinetic energy of that second car is going to be 1/2 of 0.7 times its velocity squared, and its velocity is, remember, positive 0.2. So we're going to do 0.5 times 0.7, and then we're going to take that times 0.2 and times 0.2 again, or 0.2 squared, and this side becomes 0.014. And so now we're going to take 0.004 times 0.014. I'm going to add these two things together, and when I do that, I get 0.018 joules, and that would be the final kinetic energy. So our original is 0.025, our final is 0.018. So obviously, it did not conserve energy, and because of that, the collision is not elastic. So it is not elastic, and it's because. So we're going to put because the change in energy is not conserved. And those are the 2 points. You had to find these energies, and then you had to say that the collision is not elastic because energy is not conserved. So those would be your 2 points for this last one, and then that is the total 7 points